So hello students, hello, welcome once again to our TEJAS series. So that's the second question which you would have got as a post. So we have to evaluate it. So now see, looking at this form of the angle within cos and sine, what does it tell us? It tells us, it reminds us about the concept of roots of unity. So using that concept, we have already solved few questions based on roots of unity, but still I am discussing it because few students might be seeing this video for the first time on this channel. So for them, so I will revise, recall, rewind few things here, and that is the roots of unity are actually the roots of this equation, and the roots are 1 alpha square alpha raised to the power n minus 1, where we need to understand and know that the alpha, the value of alpha is cos 2 pi by n plus iota times sine of 2 pi by n. So that's the first complex root of unity, whereas in general alpha raised to the power k is cos 2k pi by n plus iota times sine of 2k pi by n. Okay, now looking at that thing only, I said that this gives me the idea of use of roots of unity, but then you will say it is cos 2k pi plus iota sine 2k pi. Here it is cos 2k pi by 10 minus iota sine 2k pi by 10. Achha, before that, see, this number gave us that n is 10. So we are talking about 10 roots of unity. So we are talking about 10th roots of unity, bachcho. Okay, so we are talking about the equation, the roots of equation z is power 10 minus 1 equal to 0. So that's one thing we should keep in our mind. So again, coming back to the point, minus iota. So we will take care of that part by saying, so let that, are we representing? Yeah, zi. So zi be cos of minus 2k pi by 10. So I think it's better that I take, instead of I take it as k. Okay, so zk. And then plus iota times sine of minus 2k pi by 10. How will it make the difference? See, now let's come to the geometry again. See, the roots of unity when marked on the argand plane, they give us the vertices of n-sided regular polygon. What does that mean? So if this is first root of unity, of course 1 is the first root of unity, it will always lie on the positive side of the real axis, and then alpha is somewhere here. So how much is this angle? This angle is nothing but 2 pi by n, and then we have alpha square, and this angle is again 2 pi by n. Okay, and then this is alpha raised to the power n minus 1, and this is alpha raised to the power n minus 2. We shouldn't forget, we have already discussed it in previous our videos and solution, that the first complex root and the last complex roots are conjugate of each other. Similarly, the second complex root and the second last complex roots are mirror images or conjugate of each other. Okay, so that means if this is 2 pi by n, and if you rotate in anti-clockwise direction from the positive direction of real axis, the angle is measured to be a positive angle. But if we rotate it in clockwise direction, this angle is minus 2 pi by n. Okay, so this angle will be minus 4 pi by n. Yes or no? So what does that mean? So therefore z1 is cos of minus 2 pi by 10 plus iota sine minus 2 pi by 10. So isn't that alpha raised to the power 9? Alpha raised to the power n minus 1, n is 10, alpha raised to the power 9 here. All of you agree or not, bachcho? So it's alpha raised to the power 9. Similarly, if I write z2, it will be cos of minus 4 pi by 10 plus iota sine of minus 4 pi by 10. Won't that be alpha raised to the power 8? So what's happening? Actually what's happening is we have just reversed the case. Now we are moving from this direction coming to alpha at the last. So that means z9. So what is it? So if I go for the last one, z9 will be alpha in this case. Okay. So z9 is alpha. Instead of the first root, it's the last root. So we have just reversed the direction of angle. So the last root in the alpha raised to the power n minus 1 in under normal circumstances for roots of unity is the first root, and the first root is the last root. In any case, we are going to get the same 10 roots of unity. Okay, so doesn't that means if I know that sum of all the roots of unity is 0, so it remains 0. Whether you write from alpha raised power 9 till 1 or you go from 1 till alpha raised power 9. Moreover, if we know that z raised power 10 minus 1 can be written in factor form as z minus 1 into z minus alpha square and so on, z minus alpha raised power 9. Is anything going to change? Answer is no, because roots remain same. Roots remain same. Roots are same, bachcho. Okay, now see, let's see what do we need. So we need here 1 minus z1, so 1 minus alpha square, 1 minus alpha cube, and so on, 1 minus alpha raised power 9. Mod. Absolutely we need this mod, so we'll bring this to the left hand side denominator. So we have z raised power 10 minus 1 upon z minus 1, and we have already discussed this thing earlier also, I think. So it's z minus z1 which is alpha, z minus z2 which is alpha square, and so on, z minus alpha raised to the power 9. So if you compare it with the expression whose value we want, we can see that we have to put z is equal to 1. Now look at this expression. Can't we compare it as with the sum of 10 terms GP? Formula for 10 terms GP sum is A. The first term r raised power 10 minus 1 upon r minus 1. So compare it, can't we say that A is 1, r is z, and n is 10? Okay, so what is it? So that means I can replace LHS, because see, you can't just evaluate this by putting z is equal to 1 here. So if I write it as n term GP, 10 term GP, so 10 z is power 9. Now this is z minus alpha square, and so on, till z minus alpha raised power 9. Now put z is equal to 1. So what do we get? We get 10 here, and this is 1 minus alpha which is z1, 1 minus alpha square z2, 1 minus alpha cube z3, and so on, 1 minus z9 alpha raised power 9. Take modulus. Since complex numbers are equal, their modulus will be same, and modulus over complex number over the product of complex number get distributed over the product. Okay, so after taking modulus we can write, so mod of 10 is 10, and the mod of 1 minus z1 into mod of 1 minus z2 into mod of 1 minus z3. Okay, so that's the property of modulus. I am repeating, it gets distributed over the product. So if you bring 10 to the LHS, that's what we need. So what are we left to the denominator of RHS actually? So what are we left in LHS is 1. So that should be the answer of this first part. So the answer should be 1. Okay, so if anyone have got this answer, did get the answer, so it's a really appreciable thing. Okay, now let's move to the next one. Next one seems to be quite a simple one, because see, if you add them, so I will start from here, the sum of all the roots of unity. So if I rewrite it again, so 1 plus alpha is in that case minus 2 pi by 10 plus iota sine minus 2 pi by 10 alpha square cos of minus 4 pi by 10 plus iota times sine of minus 4 pi by 10, and so on, this is equal to 0. If I collect just the real part, so real part is 1 plus, or if I just write it in terms of summation, so that will save some energy and time also. So summation is cos of 2k pi by 10, where k goes from 0 to 9. Okay, and this is 0 because see, 1 is cos 0 pi by 10 and iota sine 0 is 0, so we don't need to mention it. Okay, so now see, sum of all the roots of unity is 0, and if we like compare the real part both the sides, so sum of all real part in LHS is 0, sum of all imaginary part in LHS is also 0. So this is nothing but sum of all real part in LHS, which is equal to 0. Now just put this value here. Just put this value here. So the answer is 1 minus 0, which is 1 again. So answer for both the parts, the first and the second part, is 1 only, bachcho.